All right, here we are. Guys, welcome. I'm not normally going to start with a video of myself like this. That's new and exceptional. But today's the first lesson of grade 11 university that's going to be a video cast. And there's going to be a lot of these. But I don't want you to think of that as a negative thing. It's a cool opportunity to do kind of the lesson portion, the portion where you just kind of be sitting and listening to me talk anyway in this setting, so that when we are together, when we're in the room together, what you then have a chance to do is get help with the things you need. That's the idea anyway. So today's lesson is a quick one. It's about the scientific method. And when it's done, your assignment is going to be to design a little experiment. But first, we're going to talk about the elements of a good scientific experiment and what makes a good scientific question. With that in mind, we're going to do this thing. You should have this note in front of you. And we're just going to go through this together, and we're going to review what the scientific method is and sort of what makes a good scientific question and how we can formulate one and all that jazz. So with no further ado, here we go. Review the scientific method. And the first thing we want to keep in mind is that all science starts really with a question. It starts with a specific testable question. All right, so good scientific questions are ones that we are able to test. Bad scientific questions are ones that we can't. You know, a bad scientific question would be, what's better, Pepsi or Coke? We can't test that for a lot of reasons, one of which is just that the word's vague. What do we mean by better? What's a better pop and what's a worse one? There's a lot of ambiguity there. And so a good scientific question would be, which has more sugar in it by weight, Pepsi or Coke? Because that's something we can really easily test and get a good answer to. So it has to be a specific testable question. And once we have that, if you remember, we do something called a hypothesis. And hopefully you remember what a hypothesis is, but it is a you're probably used to you hearing the word guess, all right? It is a guess, but really it is a possible answer to the question and it's what we're really going to test. So all science starts with a question, and we call that question good if it's a specific one and a testable one. But then what we actually do when we do science then is not just ask a question, but we try to answer it. And so we suggest an answer. We call that answer an hypothesis, and we test whether that answer is true or not. And that is kind of at its most basic what science is. It's testing a hypothesis. Now, after that, after we have a question and a hypothesis, we choose appropriate tools and necessary materials. And we design a specific way to test our hypothesis. We design a specific test for our hypothesis. All right, and when we do that, we have to look at a few things. Again, the question is, what makes a good scientific test? And that's not necessarily immediately obvious either. All right, but a good scientific test, a good method of testing something scientifically has just 3 parts to it. It has an independent variable, a dependent variable, and it has controls. Oh, all right, so the independent variable is one thing we change directly and measure. All right, and when we get to in a moment where I give you an example, that'll make more sense. But for now, we can say the independent variable is a thing that we change directly. We change on purpose, and we measure it. And then the dependent variable is something we measure to see if it changes. All right, so we change the independent variable on purpose, and as we change the independent variable, we look at the dependent variable and we see if it changes or if it stays the same. All right, and that's the foundation of good science, is that we change one thing to see if that causes something else to change. And then for controls, we say that everything else should be kept steady or kept constant or kept unchanged. And I'll tell you what I mean by that. If I were doing a study to see, whether coffee or tea does a better job of keeping me awake, I would, in one study, drink just coffee. In another study, I'd drink just tea. But between those 2 studies, I'd want to keep everything else the same. So I'd make sure that I got the same amount of sleep. I'd make sure that I didn't change my diet. I'd make sure I didn't exercise more one day or the other. Everything else I would keep under control. I would keep it unchanged. Right? And then as you're going to make observations. And there's 2 main types of observations. The first are what we call quantitative, right? And these are measurements, numbers. All right, so anything we use an instrument to measure that gives us a number is a quantitative observation, and anything else is a qualitative observation. All right, and these are things we use our senses to observe. How something tastes, how something feels, how something looks. All of those are quantitative observations. Right? And those are the 2 main types. All right. And then when we come to our conclusion, we will either confirm our hypothesis or reject it. We will either say that the observations we made confirm or at least support our hypothesis, or that they reject our hypothesis. They say that our hypothesis isn't true. And just keep in mind that anything we are not in control of is a potential source of error. All right, so we quite possibly have a source of error if we aren't in control of something. All right, so all of this leads us to an example. And I'm going to do an example here. And then when I'm done, you're going to design your own experiment. And you're going to come talk to me because you're actually going to carry this experiment out over the next couple of days. And then you're going to start to write a report of it. And that's going to be our practice. So I'm going to come up with a fake example here, but you're going to come up with a real example and test it. And you can work with a partner or work on your own, but no more than 2 people to a group. So the first thing you need to do is to come up with a question. And for your practice lab, your first lab of the season, you can ask absolutely any question you want. It can be silly, complicated, it can be really sciencey. Really, the sky's the limit, up to you. But I'm going to say, for example, does how high I hold an eraser off the ground affect how long it takes to fall? Okay, now, that's a good scientific question because I can test it. All right? And I'm going to make a hypothesis, which is my hypothesis is that, and this is just an example, the height will not affect the time required for the eraser to fall. By the way, if I haven't mentioned this already, I'll mention it now. Don't write this in here because this is just my example. You're going to write your experimental design in this space. All right, so don't write this one. If you've started to already, I'm sorry. You can just erase it or cross it out or whatever. But you're going to put your question, your hypothesis, and all your stuff. And then you're going to set out to start designing your experiment. And so what we're going to do is we're going to say, okay, I'm going to come down to this section and take a look. And I'm going to say, okay, well, I am testing whether height affects time. Right? So the thing that I'm going to change on purpose is the height. And that's what we call our independent variable. So mine is going to be the height of the eraser. And I'm going to measure that in centimeters. And my dependent variable is the time to fall. And I'm going to measure that in seconds. And then what am I going to control? Well, I'm going to control the same ruler, the same stopwatch maybe, the same person dropping that eraser, same eraser. Right? I'm going to drop the same one each time. I'm going to do it indoors, so there's no wind. And these are all things that we're going to control. And this is the way we design an experiment, which is we decide what we're going to change on purpose. We decide the thing that we're going to observe. And then we decide everything else which we're going to keep the same. And then from there, it's just a matter of coming up with a list of materials and methods. So here again, we would have a ruler, a stopwatch, an eraser. And really, I think that's all I need, isn't it? And then method, we want to design it very specifically. I would say maybe I'm going to hold my eraser 30 centimeters above ground, release the eraser, and start stopwatch. Stop the watch Oh my. When the eraser hits the ground, I'm going to record time, and I'm going to repeat for 5 different heights. And that's going to be my experiment. All right, and this is the stage I want you to get to today, or by tomorrow's class anyway, which is I want you to ask a question. All right, come up with a good question, come up with an hypothesis, and then we're going to take a trip down to this side, and you're going to figure out what your independent variable is, what the thing that you're changing on purpose is. You're going to figure out what your dependent variable is, which is the thing that you're observing, and then you're going to figure out what all your controls are. And then once you've done that, you're going to use some time and come up with a list of materials and a method. And again, I want to be very specific that these are actually things that you're going to do in the lab. So if you have any questions, please come see me. Hopefully just about the time you're finishing this lesson online, I should be finishing my lesson with the grade 12s, and I'll be able to help them with their seat work, but also help you with yours. But if I haven't quite finished yet, you can get going, and you can start thinking about what kind of question we want to do. So that's all for today. And yeah, get to work, guys.